Introduction to Trigonometry. It covers the first part of exercise 10A. It's finished an exercise on similar triangles, and trigonometry is about similar triangles, only it might not seem it anymore because we introduce weird words like sine and cosine and tangent. But trigonometry really is nothing other than saying if I have lots of similar triangles that all right angles, all like down here, we have right angles in right angles in these triangles and also in the blue ones down below. If I have lots of right angles, and maybe I can even draw a triangle this big, and that means there's going to be a ratio of sides that is exactly the same for all of these triangles. And this sort of constant of proportionality that holds for all triangles with this particular angle, we can hold in trig tables. Your calculator has all those trig tables for you. Back when I first learned trigonometry, we still sometimes had the tables written on a big sheet in case somebody didn't have a calculator. You guys will all have calculators, and all of your trig tables are kept in the calculator. And these trig tables are based on certain relationships of sides. So it says if I always take the bottom side here and divide it by the vertical side, then I'll get a certain ratio. And that ratio will be the same if I take the bottom side on a longer triangle, on a bigger triangle, and divide it by this one. And it will be the same again if I take this whole long side and divide it by the vertical side. Then it will be the same too. And that number is what your calculator holds. So before we go on, we need to learn to label the triangles a little bit so we can talk about them. And in any given right angle triangle, we always call the longest side, the side opposite the right angle triangle, we call that the hypotenuse. Hypotenuse. Okay, hypotenuse. And we abbreviate that to make it a little bit easier. We abbreviate that hype. Okay. The other two sides are the legs of the triangle. Depending on which angle you're talking about, they get different names. So if I'm talking about this angle here, if this is the one I've kept all the ratios in, that I'm looking up the ratio for in my calculator, then the leg that touches the angle, that makes up the angle, will always be one side, it'll be the hypotenuse, on the other side it'll be one of the legs. And the leg that is included in the angle is called the adjacent. Adjacent in English means next to, and so this is the leg that is next to the angle in question. And the side that is across from it over here is called the opposite side. Instead of saying across from it, I could have said the side that is opposite the angle is over here. Again, we have abbreviations. We can call this ADJ for adjacent, and here we can call this OP for opposite. I'm going to change colors. If I were talking about this angle here, same triangle, just looking at the other angle, then the hypotenuse always stays the same because it's across from the right angle and is the longest side. But this angle no longer touches this side. It now touches what was the opposite side. So we have to change the names if we're going to talk about this angle. This angle has this side over here as the adjacent, and this side over here as the opposite. So watch out for that. You have to be very clear as to which angle you're looking at before you start, because the names can be different. So if you need to at the beginning, always label them first. And then we have three different ratios. One is called the sine ratio. These names come from Greek and Arabic and people working with circles. There's a history as to why they're called this that I won't go into now, but if you're interested, you can ask me in class. Okay, we have the sine ratio and we have the cosine ratio. It's related to the sine ratio, that's why it has the co out in front. And then we have the tangent ratio. These words never exist by themselves. They always exist in relationship to an angle. So we call them functions because they change an angle into a ratio. If we want to use the sine ratio, then we always say the sine of some angle, and we abbreviate it with sin. If we want to use cosine, then we abbreviate it with cos, and say the cos of some angle is equal to a ratio. And if we have tangent, then we abbreviate it with tan, and we're going to take the tan of some angle and turn those into ratios. If I find the sine ratio of this angle, let's call this theta. Theta is a Greek letter of the alphabet, and it's a circle with a curved line through it. Yeah, it looks something like that. It's italic in a textbook, and it's just another variable. Sometimes in mathematics, if we get tired of using A through Z or A through Z, then we can turn to Greek letters and use them instead. So this is a Greek letter. I think it's around where a T would be in our alphabet, somewhere around there. So this is theta. Okay, and if I want to find the sine ratio of the angle here, the sine is always the opposite side over the hypotenuse side. So I would find out whatever the opposite is and divide it by whatever the hypotenuse is, and that would give me the ratio of the opposite to the hypotenuse of all of the triangles that have this angle and right angle in them. Cosine is always the adjacent side divided by the hypotenuse. So for this angle, that would be this one over the hypotenuse. And for tangent, it's always the opposite over the adjacent. I could have gone the other way around. Instead of opposite over hypotenuse, I could have done hypotenuse over opposite and hypotenuse over adjacent, and adjacent over hypotenuse. That's possible too. Those are called the reciprocal ratios. So there's actually 6 trig ratios, but these 3 give us everything we need for now, so we'll just stick with the 3 of them. And this covers all the relationships of all the sides. So if I know the angle and one of these things, I can figure out the other side, and if I know both sides, I can figure out what angle this is. So this helps us to be able to calculate things about triangles that we don't know already, or that we haven't had a chance to measure. If I change angles, I'll go up and do this angle instead. Let's go back to pink to do that. And maybe we call this alpha instead of theta. If I want to figure out these ratios, then the numbers will change, but these formulas don't change. I just have to make sure I use the right side. So the sine of alpha is also going to be opposite over hypotenuse. But it'll be a different side. Whereas with the theta, the opposite was this side divided by the hypotenuse. The sine for alpha is going to be this side divided by the hypotenuse. So as long as you've labeled your triangle correctly with the right sides, then you just always use these 3 ratios. Those 3 ratios are pretty important, and you have to find a way of memorizing which ratio belongs to which sides. A mnemonic that people have been using for years is so katoa. The S in the first word stands for sine. The O stands for opposite. And the H stands for hypotenuse. And that's to help you remember that the sine of an angle, if I take the sine of an angle and find out what it is, it'll be the ratio of dividing the opposite side over the hypotenuse. So just from so, you can remember sine is opposite over hypotenuse, and that makes so. And ka does the same thing for cosine. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. Okay, that's it for Introduction to Trig. You're ready to try the next video.